Alright, so today we're going to be talking about scatter plots and lines of fit. Introduction for how we can use calculators to write equations with lines based off data. So a scatter plot shows a relationship between a set of data with two variables graphed on ordered pairs on the coordinate plane. And we can use this to investigate a relationship between these two quantities, whether we have positive and negative relationships or if there is no linear relationship. Now, there are some problems that may not necessarily have a linear relationship, but are related in some other way. Quadratic, exponential, stuff like that. We will investigate those at a later date. For now, we're only looking at linear relationships. So this kind of scatter plot right here, even though, yes, they're all not a perfect straight line, but they all seem to have the same general trend. As we are increasing our x value, the y value is also increasing. This is a positive correlation. Over here, same concept, but now we're decreasing our y's, or x is increasing. This is what we call a negative correlation. We can kind of draw a linear line through those points. Something like this has no relationship in the slightest. There is no positive or negative correlation. As I'm increasing x, I sometimes increase y's, but I also sometimes decrease y's. It's all over the place. This is a truly random scatter plot, and we cannot assume any sort of data from this kind of problem. We can only assume data and predict values based on positive or negative linear correlations. So lines of fit are created when our scatter plots have a positive or negative correlation. You can attempt to use your calculator to create a line of fit based off a no correlation situation, but your line it's going to be awful. It's not going to work in the slightest. So we use these lines to model approximately what a line the data is going to create. To do this, so we can predict future values. Now, this is incredibly inaccurate to do by hand. We're going to need calculators for this kind of thing. Again, you can kind of like try and map out approximately if I go back. Like, okay, let's say maybe if I start here and go to there, that seems like a nice line that maybe fits the data. I can do a general approximation. I'm not saying you can't. It won't be as accurate as what your calculator can do. So that's what we need for this kind of stuff. So your calculator will need a stat button on there. So the ones I use in my class are the TI-36X Pros scientific calculator. It's about $20–25. If you have a graphing calculator, any one will do. The newer model, like the 84 Pluses, are a very good one to use in this situation as well. Now, we're going to talk about that tomorrow, our next lesson. Today we're going to be talking about linear interpolation, how we can use this to predict values that are inside a given range of data. So, we want to use linear interpolation to determine what is the y value when x is 3. Now we have this data table right here. As you can see, x's are increasing at a constant value and y's are generally increasing as well. So not always by the same number, but they are increasing. So this would represent a positive correlation if I were to plot all these points. Now, how I use linear interpolation? Well, we're just going to go to the x values that represent the outside ranges of what we want to figure out, and use those 2 points right there to find the slope of a line, and then use that line to predict what happens when x is 3. So we're going to find the slope of these points right here. So do 2.6 minus 1.2 over 4 minus 0, which is 1.4 over 4, which is 0.35. And we're going to use our 0.35 with one of the coordinate points to write the equation of this line. Now, I'm going to use the 0, 1.2 coordinate points since this represents my b value for this particular line. So my line I'm going to use is y equals 0.35x plus 1.2. So again, I'm assuming a linear relationship between here and here. So I'm going to plug in 3 for x, y equals 0.35 times 3, to solve for the appropriate y value that would work in that situation. And when I multiply that whole thing out nicely, we're going to get y equals 2.25. Now, that is certainly one way to do this equation. There's actually another way. We don't necessarily need to write what the equation is going to be, the 0.35x plus 1.2. If I instead go back to my y minus y1 equals m times x minus x1. The y1 and x1s represent the coordinate point I want to use, the easiest one possible. My x value, well, that represents what x value I want to know. I'm going to plug in. So I can do it like this instead. I can say y minus 1.2 equals m times my x is 3 and my x1 value is 0. So this gets me y minus 1.2 equals 0.35 times 3. When I add 1.2 to both sides, I still get 2.25. So I'm actually going to use this at all times. You can write the equation if you would like. It's an unnecessary step. We don't need to quite do that. We can just plug immediately everything in except for y, or x, depending, into quarter points, slope, and the given value x or y. So, use linear interpolation to determine what y is when x is 9. So now we're going to use these points to find my slope. So my slope is going to be 5.5 minus 3.9 over 12 minus 8. We get 1.6 over 4, which is 0.4. So now I'm going to plug everything in to my y minus y1 equals m times x minus x1. I want to find y, so that's the unknown. So y minus, it doesn't matter which point I use, I'm going to use 3.9 equals my m is our 0.4. Our x value given to us is 9, and the appropriate x value, the 3.9, is 8. So when I subtract that to multiply by the 0.4, we get y minus 3.9 equals 0.4. When I add 3.9 to both sides, y equals 4.3. So there is my approximation based off this. So I want you to do this one on your own. You're going to use the exact same concept we just talked about. Find the slope for this situation, 22.3, meaning it's in this set right here. And then plug in this for x, one of those points for x1 and y1, your m value just found for the m, and solve for y. So pause the video while you work that out. Okay, so you should be getting y to be 8.905 for this prediction using your linear interpolation concept. Okay, so that's it for this video. Next video we're going to talk about how to use your linear regression function on your calculator to write equations of lines. In the future you might like that better than using linear interpolation to find it because it's a little bit more accurate. It's using your calculator functions to get an answer. It's your choice. Okay, so I will see you next time.